Go back to linear algebra. Let's jump it on you. Boom. What is, or is it true that the inverse of A is equal to 1 divided by A if A doesn't equal 0? No, because matrix division is not defined. Assuming that A and B meet the size requirement to be added and subtracted, how might you compute A plus B and A minus B? You add the corresponding entries of A with the corresponding entries of B, and you subtract the corresponding entries of A or B from the corresponding entries of A. All right. I think we're in the middle of a problem, but I'm going to grade what I did yesterday just in case there's anything, and then we'll go from there. All right, nothing to grade, so I'm just going to keep working through the next problems. All right, guys. So we finished this 19 yesterday. We had to find the inverse of A and then multiply it to B. Today we just have to multiply the inverse of A times B, which is right here. This is where we started. Here's the result that the arithmetic may or may not be right completely, but we're going to find out. Didn't think it was worth the time to check all of it. Then we did a proof. So prove that if AX equals 0 is a homogeneous system of n linear equations and n unknowns that only has the trivial solution and k is any positive integer, then the system of a to the k power x equals 0 has only the trivial solution. So I think this is actually pretty straightforward. If AX equals 0 and A is an n by n matrix, A is invertible by the equivalence theorem. If A is invertible, then A to the K is invertible because the product of invertible matrices is invertible. If A to the K power is invertible, then the system A to the K times X equals 0 only has the trivial solution by the equivalence theorem. All right, true or false? First one was simple, second one got me tripped up a bit. So this was a linear system can only have one solution. I said that a linear system can have exactly two solutions. I said that's false. It's impossible for that to happen. So I said the question said it's impossible for a linear system to have exactly two solutions. I said true. Linear system can only have one, none, or infinitely many solutions. The second one was more difficult. Basically, it was saying if A is an n by n matrix and S is an invertible n by n matrix, then if X is a solution to the system, the inverse of S times A times S times X equals B. Let S of X, or then S of X is a solution to the system. AY equals SB. So what I think here, Y is the solution set, so we plug in S of X here. That's one of those, like, one of the ifs for if I got this right. If that's true, then that's a lot better chance that I got it right. Basically, here's the original first statement. That's the second statement. We want to get these things to be equivalent statements. So what I do here is I take the second statement, plug in the solution value, and then basically when it's plugged in, I take both sides by the inverse of S and then plug it in. So that cancels out this on this side and gets this inverse S over here. So really, if matrix multiplication is associative, which I think it is, then yes, this true or false statement is true. So we're gonna find out if matrix multiplication is associative tomorrow. I know it's not commutative, but I think it is associative. So if not, then it's not true. So all right, that's it for today. Talk to you tomorrow. See you.